Hi guys, so we are going to go ahead and take a look at our notes for today. We are looking at random sampling and population inferences. Okay, so let's take a look at this. Random samples. It says everyone in a population must have a blank of being selected in order for the sample to be blank. Okay, everyone in the population must have an equal chance of being selected in order for a sample to be random. A survey, for example, a survey is taken of favorite sports in 7th grade, but only girls are surveyed. This is considered a biased sample. Okay? So this is considered a biased sample, and therefore it is not a random sample because only girls are selected. Girls sometimes have different preferences than boys, so we need to take that into account. There needs to be an equal chance that girls and boys can be selected to be chosen to be sampled in order for this to be random. So we need to read the situation below, then determine if the various methods would produce a random sample. Justify your thinking in the space below. So we have the senior class president would like to host an after-school graduation lock-in. There will be games, gifts, and food. In order to decide if people would be willing to buy tickets and attend, she has decided to conduct a survey. She will select 25 students to meet and give input on the prizes, food, and ticket price. There are 500 members of the senior class. So we need to figure out some different ways that she could do this, and it would still be considered a random sample so that everyone gets their voice heard. So the first one, she selects every 10th student as they get off the bus in the morning. Okay, so I see that being pretty fair. She's selecting every 10th student getting off the bus. It's random. She's not selecting a specific group of people. She's not selecting only girls or only boys. So we could say here that it's random. She is not selecting just girls or boys. She is selecting every 10th student. And I think it varies who's riding on the bus. So I would say that would be a random sample. So I'm going to give this a green check as to I would consider this a random sample. She asked her choir director to allow her to survey the choir. So if she's asking the choir director to allow her to survey the choir, she's only asking the people in choir. Obviously, people in choir might have different opinions than just randomly picking someone out of the student body to survey. So she's only surveying people in choir. Okay, I don't know if I would say that this would be random because the people in choir, she could have friends in choir. She could have chose that group because she knows the most people in there. So it is not random. So we're going to give this one a red X. This is not random. She meets with the counselor who selects every 20th student on the roster. Okay, so the school roster, I should say. So the counselor's looking at the school roster and they are selecting every 20th student. There's no specification that there's only girls or boys, and there's no specification that she's only choosing from a specific group of people. It's every 20th student on the roster. So I say that this would be a random sample. Give it a green check. This next one, she assigns each senior a number and randomly selects 25 numbers. Well, she's not specifically saying she assigns each senior girl a number or each senior in basketball a number. She assigns each senior a number. So I would say that this would be a random sample. So she is randomly choosing from a whole class or whole senior class. So I would say this is random. She makes an announcement that people interested should meet in the library after school. So people interested should meet in the library after school. Now this one is kind of tricky here. Maybe some people that can't make it to the library after school because they have to ride the bus home or people are being picked up from school. She's not taking into account that those people aren't getting to fill out the survey. So not everyone would get to participate. Only the people that show up to school would get to participate. So I would say this is not random. A roster of the senior class is printed and each student's name is put into a hat. The principal selects 25 names. I would say this is about as random as it gets. The principal is selecting 25 names out of a hat. Names are drawn at random. Okay, I would say that is very much a random sample. All right, so let's go ahead and go to the next page, population inferences. So once a sample has been collected from a population, and blank about the entire population can be made by setting up a proportion. Ooh, I know some of you guys love proportions, and they are making a comeback, absolutely. So an inference can be made from setting up a proportion. So an inference is kind of like an educated guess, or you're able to kind of predict something. These inferences can be used to compare different populations and make predictions. Kind of like in science when you make a hypothesis. Okay, so we're going to use the information below to answer some questions. It says Eastside Middle School conducts a survey of randomly selected 6th graders to determine which elective they are most likely to participate in. The results are shown on the table. We have Spanish, 14, theater, 20, and then art, 6. It's asking us first how many students were surveyed. Well, let's add them all up. We have 14 plus 6, which is 20, and then those two plus 20, which would be 40. So 40 students are surveyed. What percentage of students surveyed selected Spanish as their elective of choice? Okay, so we can set this up as a proportion here. So we know that there is 40 in the total student selection here. And 14 of them selected Spanish. Maybe if I could write 14 instead of 16. All right, 14 of them selected Spanish. Okay, and you might remember when we are setting up proportions and we are trying to find percentages, we can set that equal to x over 100 because percentages are always out of 100. So, and then we just do our cross multiplication. So we go here, 14 times 100 equals 1400. And then 40 times x equals 40x. And then at this point, we can divide both sides by 40. Sorry, there's not a lot of space here. And then we have 1400 divided by 40. You are more than welcome to use your Desmos calculator for this. 1400 divided by 40 would be 35. Okay, and then 40 divided by 40 cancels out, so you get 35 equals x. Now remember, x is a representation of over 100, okay? Meaning that 35% of students chose Spanish. The school estimates that there are actually 350 students in 6th grade. Using the sample, find out how many students can be expected to sign up for art. Okay, so we have to do some scaling here. So we know that 6 out of 40 students that were randomly sampled signed up for art. We need to figure out how many students out of 350 are going to sign up for art. We're going to make a prediction based off of our inferences and figure out how many students would sign up for art. So just like the last one, we cross multiply. 40 times x is 40x. And then 6 times 350 would be 2,100. And then we go ahead and we divide both sides by 40. This cancels out. You get x by itself. And then 2,100 divided by 40 would be 52.5. Obviously, you can't have half of a student, so we could round this up to, we expect that 53 students would sign up for art. Okay. The school estimates that there are actually 350 students in 6th grade. Using the sample, how many students can be expected to sign up for theater? Okay, so we set it up just like the last one. 20 over 40. 20 out of the 40 selected signed up for theater. It needs to be set equal to x, which is our unknown, over our actual population, 350. Okay, and we go ahead and we can cross multiply. 40 times x is 40x equals 20 times 350. Which would be 7,000. We can go ahead and divide both sides by 40. This cancels out. You get x by itself. And then 7,000 divided by 40 would be 175. So it can be expected that 175 students are to sign up for theater. So the school decides to drop any elective in which less than 10% of the population has signed up for. Miguel says that since only 6 people signed up for art, it should be dropped. Explain why this is or is not correct. Okay, so we can go ahead and find the percentage of how many people signed up for art based off of some proportional relationships. So we see right off the bat, 6 people signed up for art, 6 out of 40. We can find that percentage by setting it equal to x over 100. Cross multiply, 6 times 100 is 600. And then 40 times x is 40x. Divide both sides by 40. This cancels out. You get x by itself. And then 600 divided by 40 would be 15. So this says that 15% of students would be signing up for art. So is Miguel correct or incorrect? Okay, if he thinks art needs to be dropped if less than 10% of people are signing up for it, is he right or is he wrong? I want you to go ahead, write a little note down here why he's right or why he's wrong. And then the last one, mark each of the following statements as true or false based off of the data. Okay, first one, over half of the students at Eastside Middle School will select theater for their elective. Okay, is it true or is it false? Why? Combined, the Spanish and art classes account for 50% of the elective results. Out of 350 students at Eastside Middle School, at least 120 will sign up for Spanish. So using the work that we did together here, I want you to go ahead and answer these last few questions. Okay, if you have any questions, please ask the teacher in the room. You can send me an email or we will go over this on Friday. So thanks for watching, guys.